All right, so I'm going to go ahead and I'll start our recording. So, welcome. This is CIS 1051. At least I hope it is, because if it is not, I need to be in a completely different room. So this course is designed for pretty much anyone who has no prior programming experience or very limited prior programming experience, or people who have a decent amount of prior programming experience without having taken a actual course for credit. So I am meeting the needs of a lot of different knowledge levels, from complete beginners to very much not beginners. So essentially, if you need credit for your first computer science course, this is the place to be. This is also designed to meet a lot of outcomes for computer science, be it as the first course that is the prerequisite for the second computer science course, for the students who just want a little bit of programming to help give them more skills to make their jobs, whatever that might be, easier. For the senior who wants to check out something before they graduate, I've had a lot of different students with a lot of different needs. Most of you are not majors, I believe, of computer science. A good number of you are. A number of you are data science or IST. But we get a lot of non-majors in this course, because we do try to direct the computer science majors to take CIS 1057, which is in C, a different programming language. Both courses fulfill the need of taking the next course, so it doesn't really matter which one you take. But I just wanted to say that you're probably in the right place here. So first off, I'm Professor Rosen. I have all my information here on Canvas. So if you ever need information about how to contact me or what my office hours are, you come here to Canvas if you don't know that off the top of your head. My email is fairly straightforward. It's andrew.rosen@temple.edu. If you need to meet with me over Zoom, my Zoom link is right there. My office hours are from 12:30 to 1:30 in the Cirque building. So that's on the third floor. I also hold office hours in the evening on Tuesdays online from 7 p.m. to 8 p.m. This is mainly designed for some graduate students who are taking an online course, but you're more than welcome to show up. And you just might be confused, but if I didn't tell you that, you might be confused as to why somebody is talking about a completely different programming language. So, but you're more than welcome to show up. If none of these times work for you, because you have other classes, you're busy, you're working, just email me. I'll be more than happy to find a time to meet with you over Zoom. I'm pretty much flexible all day Wednesday, evenings on pretty much Monday, Tuesday, Wednesday, Thursday. Sunday I'll meet. I just generally don't meet with people from sundown on Friday to sundown on Saturday. So, but other times I'm pretty much accessible. I've met students as late as 10 p.m. Don't feel like you're going to be bothering me by sending me an email and saying we need to meet at a very odd time. Some of you might be confused as to why you weren't able to find a textbook for this course, or wondering what the heck that is. If you're missing it, that's because the textbook is free. I hate the textbook industry as much as you do, if not more. So our textbook is free. There are instructions that I will go over on how to sign up for it, but we will be using an online text for it. It is free. We also have other interesting, important links here. First off, I do run a Discord for all my classes. It is a perpetual one, so you'll have tons of students there from previous semesters. Wasn't too active last semester, just for reasons, but I'm going to try to be pretty active this semester on Discord. And this is if you need to shoot a quick message that may or may not be able to be answered by other students, or by me. It's also much more casual, whereas, you can send if it's an email, you'll probably end up writing something like, "Dear Professor so-and-so, I hope this email finds you well," and then your actual question. Whereas you can simply say, "Hey, do we have an exam? When's our next exam?" And it will be a very quick and casual thing on Discord. It's weird how those social dynamics appear online. Your TAs also have their information over here. So if you need to meet with them, you can find their information here. David over here is a TA for one of the course, for one of the sections. One of the important things you should know is that the TAs all have their times listed. You do not have to go to a TA who is assigned to your section. Any of the TAs you can go to, okay? They're all there to help you. We're all going over the same content, so it's just simply more flexibility for everybody, okay? So my plan today is I do plan on going over the syllabus because I'm boring like that, but also because I really do need to make sure you understand the various mechanics of the course and want to answer those questions in advance. Then I will be going over a very, very brief history of computer science and the mathematical history behind it. Thursday's lecture will be, what we will be doing is we will be going over a kind of an exercise that will show you how to use your textbook, but it will also go over some very basic introduction to Python. More important is your first lab, which some of you already had. If you missed it, you have two options. If you missed your first lab, you have two options. Email me or your TA and we can try to help you get set up with that to go over the things we went over in the first lab. You can also email a TA in a different section and say, hey, can I pop by and hop in for this lab because I missed the first one, right? I did try to send an email saying, hey, we have a lab this first week, but sometimes students, I sign up late for the course and miss the first lab, but the point of the first lab is just simply to get Python up and running on your computer. Okay, so first and foremost, the things you really need to know are at the front of the syllabus. This course is what I call flipped. It's not as flipped as the 2168 course, I would say. But for the most part, you're expected to read the textbook and watch or watch the videos I did of the corresponding chapters before coming to class. Most of our class will be low stakes in-class exercises, by which I mean they're worth 5% of your overall grade, and you're graded on participation rather than on correctness. These are to try to make sure that you learn by doing. Because I try to do as much practical exercises, and I believe in learning these initial concepts by repeated exposure of the same concept in different scenarios. Your labs are in person unless they are otherwise specified. You can find the Zoom link, the Discord link, and the link to any and all of the lecture recordings I've done on the syllabus, also on the first page of Canvas. Lecture recordings can be found here on this button that says lecture recording. It can also be found here under lecture recordings under the other important links. There will be a playlist over here when I am done with this lecture. I'll be generating a new playlist. This is the previous semester's playlist, and this looks like a single video. It is not. It is a playlist on YouTube, and you right-click on the top left, the top right over here to see it, or the bottom left to go and open it on YouTube. The reason I put my courses on YouTube is because if you can't access my videos, well, it wasn't my fault. Something else is going on with the internet if that's the case. I don't need you to like or subscribe or do any of that nonsense. I don't monetize that channel at all. It is just specifically on YouTube because that is literally the most accessible video platform on earth. And I highly recommend that you install an ad blocker so you don't have to be subjected to any of the ads. You can do, if you are interested in learning more about how to block ads and stuff like that, I'm happy to do that, but just go and get uBlock Origin or something, and the internet will be a lot cleaner for you. It's a great experience. Okay. The most important thing that's going to differentiate this class from other classes is that your homework, which I'll go over what that is in a bit, is a two-part process to turn it in. The first is you submit it. That is when we count it as whether it's late or not, whether you submit it on time. Your late work is accepted and very lightly penalized, very, very lightly penalized. But to actually receive your grade, what you have to do is demo it. That means come to your lab, show it to a TA, come to their office hours and show it to a TA, come to my office hours and show it to me, or schedule a time to meet with me or the TA outside of office hours. And you will just simply show it to us, show that it runs on your computer, we'll ask you some questions, very brief questions to explain it, and that is how you get a grade. If you don't demo it, it becomes a 0 at the end of the semester, but you have plenty of time, right? We're talking 2 weeks at least to demo your assignment, and it's just, again, part of it is also to make sure that there was not like a misunderstanding in the assignment, right? So that if there's something wrong with your assignment that was just like a total misunderstanding, we can tell you to go and correct it, no penalty, right? Okay. On the flip side, I really don't try to be a jerk about things. I really don't try to be a jerk about things, but this is necessary for me to be a bit of a jerk about. Uttering some variation of the phrase, I did not know we needed to demo our assignments to receive credit after the first exam will just get you an instant 0 in this course. The reason I have put this in there is that ever since I put that in there, nobody has ever said that to me. I used to get that all the time for students who did not demo their stuff. If you're not demoing your stuff throughout the semester, that means you're not going to lab, which means you're missing out on a lot of content. But also, it's just painful when some student tries to demo everything at the end of the semester. Occasionally I will go, okay, and it's never any good, ever. Sign up for the textbook at runestone.academy using the course name Fall 2025 Rosen. So to get to your textbook, what you do is you go to runestone.academy. You can go to log in, register, get started, or log in. And let's see. Ooh, that's a new one. Take me to the sign up page, right? You'll be asked to create a username, a first name, a last name, email, password, confirm password. For your email, so I need you to just do me a favor to make my life easier, okay? And I go over this on Canvas. Be sure to use your Canvas, your name from Canvas, or your TU email address when you sign up, okay? Right? What I mean by your TU email address is that I've listed my email address as andrew.rosen@temple.edu. That's not the email I'm talking about. The email I want you to use is this one, tu85861 at, whatever yours is, right? Or TUG. For me, it's TUG 85861. Point being is that I have a script that will pull stuff from the textbook, and it automatically matches you up based on either your name or your email. And so it just makes it easier for me because trying to merge two Excel sheets manually is just a pain. And this allows me to take two very different Excel spreadsheets and just kind of merge them together. And what you'll want to do over here, the most important part is put fall. I swear I know how to type. Fall 2025 Rosen. And that will get you signed up for the appropriate course. Okay? It's all free. If you have trouble with it, just come and send me an email or speak to me. But it is, again, there's no penalty for messing up. Worst case scenario, you just make a new account. It's not hard. It's not anything to worry about, I should say. Okay, so there's our textbook. Use your TU email as your sign-up email. Use the exact name as displayed on Canvas, otherwise you'll not get graded. I understand some of you have performed name changes just for simplicity's sake. If you don't put in your name, make sure you put in your TU email. Otherwise, when the grades get imported, you'll get a bunch of zeros, which I will fix, but I'll get around to it when I get around to it. Don't cheat in this class. I have a pretty good track record of catching cheating students, especially during COVID. The vast majority of these cheating charges were during COVID. I caught about 10 students cheating on the final exam, and no, I did not have any monitoring software on there. I laid a landmine in my exam, which went off for a lot of students when they looked up the answer online, even though I told them not to use the internet. And it was just so like I said, I tend to be a bit of a jerk about some things. Or I don't try to be a bit of a jerk, but there are some things where I'm just evil, I guess. 56 charges since fall 2021. I haven't actually had to submit too many in the fall semester. That being said, I try to be nice about these things. Some students do cheat, and they instantly regret it. And as I'll go over, I have something called the regret clause. If you perform an act of academic dishonesty, if you come to me within 3 days of this act, right, then I will basically, it's not going to get forwarded to the academic honesty department. It's not going to student affairs. We will handle it internally. I had a student who confessed that they did this on their final exam. They looked over at another student's answer. I just simply marked them 0 for that question, and that was it. I don't be, I appreciate honesty. Okay? Don't come to class if you're sick. That's the reason I record these lectures. Okay? If you're sick, you're going to be miserable. Just don't come. Catch up on the lecture later. If you don't really even need to send me an email, the only time you really need to send me an email about that stuff is if you are missing an exam. Same rule applies for exam days, right? If you're sick, just don't come to the exam. We'll find a time to make it up within a week, okay? And if it's beyond that, then you're probably going to need a medical note anyway, so, because it's going to be a mess for all your classes. So, and finally, using your AI, we'll go over AI stuff, but using your AI on your assignments will lead to failure on the exam. I won't necessarily be able to catch you, although I'll have a very good suspicion that you're using AI. It's very clear and blatant, but not necessarily provable. But I found that students who rely on AI, they end up getting like 30s on their exam, and that is not enough to pass. You need to, this is a course about fundamentals, and you really need to be able to use the fundamentals before you can really take advantage of AI. It's there. I love AI. I love the unlike a lot of professors, this is part of my domain of knowledge, right? And we have tools built into a lot of and we have AI tools built into most of our tools now that allow us to use AI in programming. But you need the fundamentals in this class. And so I know the temptation is there. Do your best to resist it. So again, as I mentioned, this is a basic programming course. It is a 4 credit hour course, meaning you have registered for 4 hours. Based off the various metrics that are used pretty much throughout all universities in the US, you are expected to do, for courses, if you are registered, for every hour you are registered, you are expected to do 2 to 3 hours of work outside the classroom. When I was taking classes, I was hearing 3 to 4, but realistically for this class, you're looking at 8 to 12 hours outside the classroom each week. This is a skill-based course, best comparable to a music course, honestly. And I say that as somebody who took music as a minor. A lot of this is just simply practice to get to do this. So falling behind, you can recover, but it's harder because you have to put in more time. The reason is because you have to make a lot of mistakes to program. And so you'll be making these mistakes, and then you have to spend time fixing those mistakes. And once you fix that mistake, when you make that mistake again, because you will, you're going to spend less time fixing that mistake until you've got basically a list running in your brain of all these mistakes that you can make when you do these things and these traps to avoid. You'll see that you will struggle with things for hours, and then you'll come to me or to David, and he'll fix it in like 5 minutes, if that.
I've been doing this for a little while, so I know what to expect.
And the difference between you and us isn't that we're smarter. We're not. The difference is that we've just made a lot more mistakes than you have. We are good at failing, so.
I've taken every math course here twice.
We've been, I'm on the other opposite end of the spectrum with math. I love math, and I was terrible at programming when I was in my undergrad. I'm great at programming now, but like undergrad, woof. But I made a lot of mistakes, and I learned from them. And you have to give yourself time to make these mistakes. Okay. I don't know why I have to list the time and place in the syllabus, because you're here. Congrats. But I do. And the labs are a bit more, this is a bit more useful because you may not know where the other lab sections are if you have to attend a different lab for some other reason. Okay. There is some basic math knowledge. I don't know if this is required anymore, 1021.
Honestly, when I took it and I took this course, I didn't use it.
The most basic math, so we will be going over we are going to be faking our way into some advanced mathematics, by which I say that you really don't need to know. I'll be going over things that sound really complicated in this class, like Monte Carlo approximations, which just simply say we're going to play this game so many times that we can cheat at statistics. That's really what we're going to be doing. We like to be lazy with our math here. The most advanced math we really need in this course is some basic trigonometry, very basic, and only for an in-class example. And I'm thinking of that's the turtle dart throwing example. That one, but for the most part, if you know what a Euclidean plane is, which is the fancy term for the XY coordinate plane that you've been doing, you're going to be fine here, right? Right? I'm not going to be asking you to memorize, to know, okay, what's the distance formula for that? I don't need that. I just want you to know, I just need to know if, like I say, hey, this object is at space 50, 100, or negative 50, 100, you know where that is, relatively speaking, right? That's pretty much where you need to be in math, okay? But we'll be faking our way to some impressive stuff in mathematics because we in fact have entire courses dedicated towards faking our way through mathematics by using computers, and that's numerical analysis. So, once again, here's the textbook information. If you need other resources, here are 2 more free textbooks on Python because I want you to have those resources. And just in case there's some issue with understanding what an office hour is, it's a bit of a nebulous term. A lot of teachers have swapped to using student drop-in hours, but these are times basically where I am guaranteed to be in the office and you are the top priority if you come in. Right? Don't feel bad about interrupting me if I was doing something else. During my office hours, you are the top priority. If you can encounter me on other times, I will probably drop what I'm doing to work with you. Probably. But I might be in the middle of doing something else. But during the office hours, I am guaranteed to meet with you. Okay? And again, if you can't meet with me, please do. There is free peer tutoring for this class and other computer science classes in Circ 358. They generally get started in the second week, I believe. That's when they typically tell me to release the schedule. I just want to go ahead and tell you now in case I forget. There's free peer tutoring available. All right. Attendance. I don't take attendance. There's too many of you. And if you arrive late, just do your best to not make too much of a disruption. We do expect you to attend. I mean, you are paying for college. You might as well get what you pay for, right? I do tend to cover more content than is present in the book. And I also happen to be prone to mentioning some questions that will appear on the exam during the lecture, and it's much easier if you're here to get that information. Again, if you're sick, just don't come to class. A lot of this came during COVID, but I had this policy even before COVID. Mental health. College is a huge transition for a lot of you. And I get that. And it's rough. I've had various situations I have at least one student semester who's in a really nasty situation for one reason or another. It's different for every student why things just suddenly fall apart. I had one student who, she was doing great until the very, 3 weeks before the end. We're talking straight A's, getting 100s on all the exams. And then she fell off the face of the earth. Did not know what happened to her until I noticed she wasn't appearing, and I had to reach out to her. And again, life just fell apart. If this happens, reach out to me, okay? Please. And if things are going, and the earlier you reach out to me, the sooner I can help you. I'm not a therapist, and I'm not trying to replace being a therapist. That's not my job. My job is trying to see how can I listen to you, and can I help you with the course load we have. I can give you options. I can explain what your best options are for the situation. Okay? So simply put, if you experience significant stress or worry, changes in mood, or problems eating or sleeping this semester, whether because of this course or other factors, just reach out to me, okay? Any hour. Again, I'm not a therapist or anything like that. I'm not trying to replace a therapist. What I'm trying to do is trying to make sure that you get the resources you need if you're in a rough spot. I'm there to help. The sooner you tell me, the more I can do. But if you start having issues week 3 and don't reach out until week 12, there's very little I can do at that point. On the other hand, if you're going out through the semester and things start at week 12, there is more I can do there because you've been attending more of the class. Okay, but like if you need accommodations because of the stuff, I will find accommodations. I will find alternate timelines to turn stuff in. I will figure out whether an incomplete is the correct option for you or not, right? If you have a accommodation based off of a disability or for some other reason, please go through the DRS office, Disability Resources and Services. Okay, they will reach out with accommodations. I have yet to find accommodations that are unreasonable. I am required to make any reasonable accommodations. Typically, these lecture videos and these recordings typically it covers like 90% of student needs that are like in class. And then like the other ones for extended time and the like, those are handled by DRS. But we haven't really found an unreasonable accommodation yet, so. Right. You can't make your own recordings of this class without telling me, right? I mean, using your phone to snap a picture of something on the board, that's perfectly fine. But we're talking about like making your own lecture recordings. That's just not allowed by the official school policy. And also technically, I think Pennsylvania is a 2-party consent state.
Yeah.
Yeah, so technically illegal. Yep. So not doubt that anybody would actually probably get you for that. But the point being is that if you need to if you want to make your own recording for some reason, just let me know. Right. I don't know why you would need something other than mine, but if you need to, just let me know. All right, tech requirements. Can't believe I have to say this, but last semester proved me wrong. So this isn't directed at you. This is directed at my anger for some students last semester. You need a computer to work in a computer science course, or at least in this one. Some computer science courses you don't, as you get more advanced, you don't need computers because we're working more on math stuff. But you need a computer or a plan to use one. Technically, it's possible to do this course without using without owning a computer ever, if you live on campus, right? Because the campus computers, the laptops that you can borrow from kiosks, the ones in the tech lab, the ones in the labs, the tech center. I'm not sure about the student centers, but a lot of these computers on campus have the resources you need to do your work. A reliable laptop is strongly recommended, especially since we will be doing exercises out of our online textbook. If you do not have a laptop, you can always pair up with a student and enter your answers later. I'm a big fan of people collaborating. If you can also always go and borrow one from the various kiosks. There's a kiosk in the library, there's one in engineering, and there's just laptops that you can use your AL card to check out, and then you turn it back in like 4 hours, right? Those will work. But you need to have a plan that you can reliably use, because otherwise you will suffer. I don't use this term lightly. Wailing, gnashing of teeth, lamentations, torment, right? Whatever biblical terms you want to use for suffering, you can put in there, because it is just a mess. If your laptop is missing like 5 of its keys, and you have to use the paste operation to use one of your letters, you're going to be having a terrible time in this course. We need to find a different solution for you, like ASAP. If you cannot afford a laptop, I will do my best to try to find a solution that can work for you. Desktops are a bit easier because you can always get a really cheap one for like $125 through the recycling center here on campus, where they basically are selling the old computers that they can't use anymore. And they were old high-end computers. I got one for my kid. It runs Minecraft just fine. It's basically perfect for doing this kind of programming stuff. And that comes with a monitor too. So if you need a desktop, that's easy enough to accomplish. But laptops, they also have the same. They're just slightly less powerful. But if you want like a good laptop, that's approximately $500, and that will carry you through college. believe it or not. If you buy a new laptop for $500, that will carry you through college. Anything more than that, you're getting additional features such as a sharper screen that's better able to use outside. That's basically the benefit of having a good screen, being able to use that outside. Or my personal favorite feature of laptops, which is being extremely light. I use a very heavy laptop for weird reasons. My laptop is extremely weird. For those of you who didn't see, it has a second screen built into it because that was a thing I needed during COVID for doing Zoom. All the Zoom controls I kept on the bottom. It was very useful for COVID, less useful now. I don't recommend this laptop to anybody unless you know exactly what you're going to be using it for. That's the case, and I knew what I was using it for. So, again, you as a student, you probably want to emphasize having something that is lightweight. If you enjoy gaming, like I do, I highly recommend actually you don't invest too much money on necessarily a gaming laptop unless that's your only computer. Instead, it might be a more viable option to have a laptop and a console, just simply because you can then have a very light laptop to carry around. Okay. So anyway, you can borrow the laptops. You can use it. You can technically use tablets. You might have some difficulty with one of the assignments, but come speak to me if you've got a laptop or a tablet or a Chromebook, and I'll try to help you get set up for your situation. Okay. Long story short, just don't come to me 3 weeks later and say, I haven't done anything for 3 weeks because I haven't had a computer. If you have a break with your computer, I understand. But even if you don't, if you live off campus and only have one computer, please, for the love of God, come up with a backup plan because Murphy has it out for you. A Murphy of Murphy's Law, anything that can go wrong and will go wrong. By entering this course, you have unwittingly let Murphy lay his eye upon you. You see, things will go wrong for you because you are in this course. Not because this course is unlucky, but because you're taking a computer science course. Things will go wrong with technology you did not know could go wrong. And they will go wrong in various ways. And you'll find at the end of the semester that, for right now, yes, the dog ate my homework. Somebody broke my computer by sitting on it. That sucks. And I will do my best to accommodate that. At the end of the semester, though, well, I'll be giving you the resources to make it sure that you can get set up within any computer in under 2 hours with all your work still intact. All right. Anyway, let's talk about grading. So we have different categories for grading. We have, but basically, roughly speaking, it's half exams, half stuff that are not exams. Okay? So solo exercises and classroom exercises. These are the give me points that I give to you. About 15% of your grade is just freebies. Solo exercises are the reading and exercises I assign in the textbook. They have soft due dates. What do I mean by that? These due dates exist, and there's no penalty for not meeting them. As long as they're done by the end of the semester, you will get credit for them. These due dates are when I want you to have these done by. And yes, some students forget to do these until like the end of the semester, and they learn a very valuable lesson in time management. But the point being is that these are expectations. These are your kind of your participation, the grades you get for studying, right? This is your incentive to study, okay? Classroom exercises. These are the stuff we do in class, okay? Once again, there's no penalty for doing these late. So if you miss a lecture because you're sick, right, you can just follow the lecture recording on your own, upload it, or do it on Runestone, and I'll catch it. The classroom exercises involve active learning, meaning we will be learning by doing. Typically what this is that I will ask a question, there will be a question or a prompt or a part of an exercise, and I'll give you time to try to work on it, or at the very least to think about it, right? And then once that time is expired, I will give you the answer, right? Because a lot of these problems do end up being a thing where you run into a problem and it could be something that's just syntax related that's keeping you from solving the problem. So I give you the answer to make sure that you can catch up with everybody. And I explain how we got there. Okay, so as a result, they're fully intended to be done by the lecture. And you can work with your classmates on solo exercises, on classroom exercises. You can turn in the same answer. You can work together. As long as what you're doing it works for learning, I don't care, right? This 15% of the grade is meant to be yours, okay? Okay. Lab assignments are your homeworks. Okay, they're analogous to homework. They make about 25% of your grade. Okay. You should expect one a week. There are some weeks where I've noted where like this assignment is lab 4 and 5, so you get one homework and it will last 2 weeks. But they are intended to be started on and started on in the lab. If not fully completed, it can be hard to do it all in 2 hours, but if you don't complete it in lab, you do it as homework, essentially. So you either are intended to be able to complete it or get a very good start on it. Okay? They're supervised by me, but usually, or the TA, usually the TA, for the introduction. Getting help from your fellow students is encouraged. I will go over what I find acceptable versus non-acceptable, and it's actually fairly straightforward, but that's in a minute. Most importantly, this is the stuff that I was referring to that has to be demoed, right? The other stuff doesn't have to be demoed. This is the lab assignments are what gets demoed, right? It gets in. So, and if you go to your labs, it's fairly painless because you do it in lab, then you demo it the next lab, or the end of the lab. I say these due dates are firm because they are there, but I accept your late work. 5 points per day, maximum half off, right? So if you completely mess up, I will, you could ostensibly turn this in for half credit because I really do care that you do the work and that you learn. Right? They're determined by when you turn it in, not when you demo it. So even if you turn it in and you demo it a week later, it's not late by a week. You turned it on time, so it's on time. You have up to 2 weeks after the due date to demo your lab. Otherwise, we will enter a 0, but it can be waived. The only reason I have this in my syllabus is because I need something on paper to be able to say no to anybody who says, I need to demo all my labs at the end of the semester for aforementioned reasons of it being utter torture. Right? Turn it, and the steps I gave, I went over there. Finally, during the last month, we will have basically finished the curriculum for this course. There are other things I could go over, like I could go into binary, and I probably will this semester. I could go over into sorting algorithms. There's a lot of introduction to computer science topics I could go over and give you homework on. But I'm not gonna. Instead, what we're gonna do is we're gonna do a final project. Think of it as a mini freshman version capstone, except way less stressful. The idea here is that you will now have enough programming language to, programming knowledge to actually do something pretty fun. And so the metaphor I use is that I'm throwing you into the deep end of the pool to let you know, yes, in fact, you actually know how to swim at this point. The objective here is to learn something new that you're passionate about. A lot of students end up doing video games of some kind, and they can be very silly or small. Some senior students often take the opportunity to use to combine it with with a project from another course. Sometimes I get music students who make VSTs or with virtual instruments or other plugins. I have students who use it on personal projects. One of the best projects I had last year was somebody who made a device to tell whether or not to detect when a gate opened or not, to let her know if the goats had escaped. It would send a notification that via email that the goats had come out with this. That was a great one. Okay, you can do the programming. A lot of students do websites, just basic kind of this is me websites, home pages. Or some students make more dynamic things. I had a student one semester make a Wordle website. It's entirely up to you what your project is. I will give you approval to make sure it's not too hard or too difficult or too easy. You're welcome to do it in any language you want, any programming language you want, any infrastructure you want, right? But do something that really interests you, okay? You're allowed to do this. You have the option of doing this as a group project because some of you will have the opinion that group projects are the worst, right? Utterly the worst. But you have the option of doing it in a group of 1, 2, or 3 people, okay? I will go over how this is broken down later in the semester. Don't worry about this for now. Although if you are one of those students who I mentioned who have a lot of prior programming experience, this might be something to talk about me sooner. We will be doing it on GitHub. Again, I'll go over that. This is the one thing that you turn into me that has a hard deadline. There is a late penalty. It is 1/10 of a point per hour. Sorry, per minute. 6 points per hour, in other words, that is late. It is due the very last day of class. The day before classes are over. Sorry, the day that classes are over. The reason for this is that I can't accept any work after that point. So that is literally as late as I can make it. We are interested in the journey, not the destination, like how you got there and what you learned. So even if you did turn in something that doesn't quite work, but it has working elements to it, that's still going to be an A, right? This is very much an A for effort if you learn something in here, where an A is defined as a 90, right? What is your incentive for doing more than just get a work? But you got to have some incentive for doing more than just an A for effort, right? So the incentive here for the final project is that the best final projects get to be exempt from the final exam. They don't have to take it. They just skip it. So the best final projects, I typically choose 1 or 2 from every section. So that is my incentive there. We'll go over that in more detail. Midterm exams. I will be having 3 midterm exams, 1 at week 6, 1 at week 10 or 11, and 1 on the very last lab. There will be 3 of them. There will be 3 midterms. We drop the lowest grade. That's why we have 3. Generally, I give 2, but I found that having a 3rd really was good for disasters, let's say, that could happen, right? So 3 midterms. There were 30% of the grade total, and we drop the lowest, okay, of those midterms exams. So each one of those that you do take will be worth 15% of your grade. The final exam is a separate exam. It's not the midterm exam, so technically they are 4 exams. But again, there's 2 midterms that are graded for you and a final exam. The final exam, we'll be going over when that is later, but that's during the final exam period. That's worth 20%. It's cumulative. The format of the final exam is as follows. You will have 7 questions. You choose 5 of them. That's it. I will go over the topics of those questions in time. One of those questions will be what I call a mystery question, but does go over for loops. And the other question I give, the last question, is typically one where it goes over something that I have not taught in class, but I give you all the documentation on how to do it. In other words, it's, have you learned to program enough that I could give you documentation and use it? Pretty much every student who's attempted that problem gets like full credit on it. All right. So academic honesty, right? There's a lot of examples here, but I'm a big believer in collaboration. I want you to collaborate with each other, and I'd rather you ask me, hey, is this okay? And ask for permission on these kind of things, because I do want you to work on these together. I believe that you really only truly master the material when you're able to teach it to others. Being a teacher, I'm a bit biased in that definition. So, but I really believe you should collaborate. You should work together, form social bonds. You should, have fun with other people on this stuff. If you have trouble completing an assignment, send me an email so I can work with you to get you to the solution. Don't just dump it into ChatGPT. Don't go to Chegg, right? Although Chegg's stock is down 90% now ever since ChatGPT came out. So that's been at least great there. But ChatGPT won't necessarily help when you have to demo and explain the work that it gives you, right? Generally speaking, the rule is as follows. When it's you who are asking for help, you can show your code to other people. Hey, my program isn't working. What in the world is wrong with it? And then you send your code on Discord. Perfectly acceptable. Sending, on the other hand, sharing a solution, right, giving somebody the answer, that's not allowed, right? So you can share your code when you are asking for help, when you are asking, hey, what is wrong with this? How do I solve this? That is perfectly acceptable, and I encourage you to do so. So reasonable examples of reasonable stuff. Communicating with classmates about assignments or to understand course material better. Helping a classmate identify a bug in person or online by viewing, compiling, or running their code, even if it's on your own computer. So having other people's code on your computer is okay when you're trying to help them, okay? Sending or showing code that you've written to someone else so that they can help you identify a bug, provided you cite the help, right? Please, if you ask, this is just to get you in practice, because this basically is your biggest defense against academic dishonesty, which is being honest. I worked with Alice Awesomeface on this, right? She helped me. Incorporating a few lines of code that you find online or elsewhere on your own, provided those lines aren't like the solution, the entire solution to the problem, as long as and that you cite those, right? And citation is very simple. Just drop me the URL in a comment, right? That's I don't need MLA or any of that. This is not that kind of course, okay? Sharing a few lines of your own code so that the person who is asked for help can fix their problem. That's perfectly fine. Looking stuff up online that aren't exact solutions to exercises, but maybe solution to a problem you're having, those are perfectly fine. Whiteboarding solutions, right? Putting them on a whiteboard. Working with and even paying a tutor to help you as long as they're not doing the work, right? Those are all acceptable. Things that are not acceptable. Looking up the solution. Asking a classmate to see their solution before you've solved yours, right? Failing to cite, the origins of codes that you discover outside, right? If you copy and paste code from a website, that's kind of trivially easy to discover. Blindly copying stuff onto exams just doesn't work. Generally, that's not academic dishonest. That's just generally you not understanding the material well enough to know that this doesn't work. Don't give even if somebody's struggling, don't give them the answer, right? Don't let them see your problem, right? Try to lead them to the answer if you're trying to help. Don't pay other people to do your work. Yeah, there's services for that. It's not worth it. Right? Searching for outright solutions on a website like Chegg or one of those other dying websites, because now they've all been taken over by or replaced by AI as resources, right? Splitting your workload with another individual, like some of my problems have multiple independent parts saying you do the first half, I'll do the second half, and we'll combine our answers. No, just don't. This one in general comes from just overall, is I believe from the student handbook in general, and general course university policy. You aren't allowed to submit the same or similar work to a course, right? You can't use an assignment twice, right? If you write an essay in one course, you can't use it in another course, generally speaking. I know that seems weird, like you did all the work, why can't I use it? But generally the issue is without approval. Like, for instance, I allow students to double dip their final project, like their final project can be a final project in another course, as long as we get permission from both instructors, right? Relying on an AI tool like Gemini, ChatGPT, Copilot, etc., to write your assignment for you. The best advice I can give is that we are treating ChatGPT as though it's another student in the course, right? If you are asking ChatGPT to say, hey, my code isn't working, what's wrong with it? And it comes back, you're missing the semicolon, or you're missing a colon, or you've got this weird little syntax error. That's perfectly acceptable. That's something that programmers do all the time these days, right? Why isn't this working? Oh, right, that's the reason why. Oh, I misspelled it. You'd be surprised how often that happens, right? Those kind of things, perfectly acceptable. But if you're telling ChatGPT to just simply give you an answer, don't do that. That's not good. And again, that does come with markers. I'm sorry this has taken so long to just go through the syllabus, but as you can see, there's a lot in here, and just kind of understand. Once again, the regret clause, 72 hours. If you do something that is just dumb and wrong, tell me. It's not going to go outside this course. I get about one student who uses a semester, and this is the primary reason I have had so much fewer academic dishonesty charges. Okay. But the most important thing about the AI is that it does have certain tells. We can tell based off of certain methods it likes to use, certain techniques, certain ways of displaying data, and certain ways of making comments. It has markers, right? And we know these markers. And yeah, it will get your assignments done. I'm not going to lie about that. But exams, they're done on paper. They've always been done on paper. I know that seems weird, but most programming interviews are done on whiteboards. So, yeah, you're not going to be able to ask for help on paper. All right, that's just a list of topics. So, with that, any questions before I go on into a brief history of computer science? Okay. Finally, the fun stuff. Okay. So, what is computer science? Because that seems like an obvious question, but it's actually a terrible name. Like a degree in Europe might not be named computer science, but informatics. It's, again, not a great name. As this quote about computer science says, computer science is no more about computers than astronomy is about telescopes, biology is about microscopes, chemistry is about beakers and test tubes. Science is not about the tools, it's about what you do with the tools. Right? It's about how we use them and what we find out when we do. It's not the study of computers, and it's not necessarily programming, although that's a big part of it. It's an understandable misconception because that's the misconception I had for the longest time. And your first exposure to computer science is a programming course. It isn't about learning about programming languages. Various elements of computer science have existed as parts of mathematics and overlap with it, and have done so for years before computer science is a formal field. And besides, once you're done with this course, once you're done with your first 2 years, picking up another programming language and understanding how it works is basically 2 weeks worth of work. It's not that particular. Some languages are a bit more difficult, like going from a C-based language to something like Lisp is a bit difficult. But, it's not that hard to pick up a new language once we learn it. We don't study specific software because what the newest and hottest software is changes all the time. But we do study those fundamentals that we can use. So computer science, though, if you really ask a lot of professors, who are really into like defining this kind of stuff, that will give you a bunch of different answers. The answer I like comes from a Java textbook. With a simple definition of computer science is the study of algorithms, and that gets the response from most computer science professors of, yeah, that's not wrong. So it is the study of how we automate problem solving. Okay, the question it's trying to ask and answer is, when we get right down to it, can we actually automate? What can be solved automatically? And furthermore, if we can automate it, how efficiently can we do so? It's got a lot of subfields as well. Theoretical computer science itself covers a wide variety of topics, including algorithms, data structures, computational complexity, parallel and distributed computation, probabilistic computation, quantum computation, automata theory, information theory, cryptography, program semantics and verification, machine learning, computational biology, computational economics, computational geometry, and computational number theory and algebra. Work in this field is often distinguished by its emphasis on mathematical techniques and rigor, right? Big kind of subfields, right? Lots of things. And that's just one part of computer science. So when we study algorithms in computer science, and that is a term I will have to define in just a bit, studying the behavior of algorithms to determine whether they are correct or not, designing and building computer systems to execute these algorithms, designing languages and translating algorithms into these languages that can be executed by the hardware, right? You got to be able to translate them, and they've got to be able to run. And then identifying the problems and designing correct, efficient solutions in this field. Okay. So let's see. Do I have? Yep. So let's talk about, since a lot of you are non-programming majors, let's talk about how even just a bit of computer science could help in one of your fields, right? There's a lot of interdisciplinary work in computer science. We have a special word for it in the biggest field. We have a special word for it: bioinformatics. Basically, if you're working in biology, chemistry, and medicine, or medicine, in design and computer science, it's bioinformatics. This is probably the biggest field for computer science, aside from like just straight up software engineering, mainly because medicine is never going out of style. It is big. Advanced problems in those kind of fields are detecting cancer, designing new medicine, designing HIV inhibitors, and my personal favorite, prosthetics, advanced prosthetics. Better arms, better legs, new eyes for people. Those kind of things are really cool, and they require computer science and programming knowledge. But even a little bit of knowledge in biology can help you do a lot with this kind of stuff. Physics and astronomy. Quantum computation's the big theoretical thing in that area right now. But also, like in astronomy, most supernovas are detected automatically by just analyzing telescopes rather than being analyzed by eye these days. There's tons of astronomy data to be sifted through. We're talking like 140 terabytes a day from a single telescope array. Engineering kind of has its own kind of just obvious implications. Business and economics. Computer science has a bunch of things for managing teams. We use a bunch of strategies, a bunch of fail-safes and stuff like that. But like, if you're really into money, the where it's at is high-speed trading algorithms, right? Being able to detect how to make money really fast with trading. A lot of trading online these days happens with bots. No, you're not good enough to do it. You got to be working for a bank to be good enough to do it. Psychology is also got its own term for its cross-sectional field. HCI, human-computer interaction, and that's where I got my research started. Basically looking at how blind users could use technology. Right. Education and technology, that's another big one. More direct applications, though: generalized software engineering, doing networking, data science, which I'm the advisor for. I wear a lot of hats in this department. I suppose now's the time to go through that. So aside from being a year professor for this course, I am the advisor for the data science degrees, the data science minor, the accelerated computer science degrees, so the ones where you do your bachelor's and your master's, as well as the computational data science master's program. I also am the person to ask if you are interested in studying Japan. Temple University does have a Japan campus, and I've taught there twice. It's a lot of fun. So, if you have questions about that, I'm the person to ask. I'm also the advisor for the TU Gamers Guild, as well as, am I the advisor still on paper for TU Dev?
Absolutely. Basically a big community for hackers, makers. The whole point of it is just so that way you guys can get involved more with technology, because this is a really difficult field that you're going to be getting into. So you got to love something about it, and we like to inspire. So keep tuned with that. We've got some stuff coming down the pipeline.
It is worth, and part of the reason I'm glad you're here today is it is worth mentioning which hats you currently wear.
Please don't. It's a long list. I need help.
What are the big clubs on campus that you're involved in?
TU Dev. I'm also involved with ACM, the Association for Computer and Machinery. I'm their web developer there. I'm also obviously MTA for your courses as well, and I'm also part of the CST STEM Leadership Fellowship. I found out about that today. Cool. But the point being is that I've put on a lot of passion trying to help guide a lot of you guys through this major, because again, it's a really difficult major.
So if you want to learn about how to connect with other students, David is a great person to talk to, okay? Because he's involved in a lot of clubs here. Okay. So with that, with that aside, let's resume. We were talking about computer science and being the study of algorithms, so we should answer the question, what is an algorithm? And I will tell you, this is a question on your first exam worth 4 points, so might as well. So the word algorithm comes from the Latinized name of Muhammad ibn Musa al-Khwarizmi. I may have butchered that, but it got Latinized to algorithmy, right? It was a Persian mathematician, and he wrote a number of very important books. One of them was called The Concise Book of Calculation by Reduction in 820. this book, the original language, it gets the first word is algeber, which that's where you get algebra from. It's his fault. What he did is that his big claim to fame is that he noticed these new base 10 numerical systems coming out of India and started working with them, which we now call Arabic numerals. And he wrote a book about how to do mathematical operations with them. And since that was a lot better than the Roman way of doing things, that kind of spread like wildfire. So that got translated into Latin, and then that spread to Europe. So that's why the name algorithm comes after him. Okay, an algorithm is a set of well-ordered, unambiguous operations that yield some result in a finite amount of time. That is a very technical definition, and I try not to be too technical in this course, but it is a very technical definition. Right? Studying algorithms began in mathematics, right? You've done a number of algorithms. The regular basic addition algorithm where you're adding two numbers together and then carrying and then adding that row, that column together, and then going on to the next column. That's an algorithm. Doing long division, that's an algorithm, right? Algorithms, when you turn them into programs, allow you to automate tasks. So let's go ahead and talk about what this means, well-ordered, unambiguous. So an algorithm, set of well-ordered, unambiguous operations that yield some result in a finite amount of time. Well-ordered means there is a certain level of direction. You may have seen, there's this hilarious clip that goes around online every year or so, which teachers or a mother tries to get children to give them the instructions on how to make a peanut butter and jelly sandwich, and then they follow those instructions exactly to hilarious results. This is what we mean when we say, like, we want well-ordered, unambiguous operations when we do a algorithm. We want a recipe. Recipes have specific steps that need to be done in order, and they need to be unambiguous because computers are dumb. This is a rock we have hit with lightning and tricked it into thinking. So, and it's very angry at us for doing so. So we have well-ordered operations. They have to occur in a certain order. Unambiguous. In other words, there's no room for misinterpretation. They yield some result. It does something. That's all that means. That's saying it does something in a finite amount of time. It will do something, and it might take a while, but it will happen, as opposed to it won't, or we won't be able to know. Okay. So there are some fundamental insights that multiple people have had about computer science, which is that we can, a lot of people throughout history have recognized this. Bacon, Leibniz, Boole, Turing, Shannon, Morse. All information can be basically encoded in zeros and ones. We're not going to get into that because I've done that. It's a headache. We will get into, like, how do you encode numbers as these zeros and ones later and why we do so. But for sake of argument, just understand we can. And then Turing came up with this idea about being able to move stuff left and right on an infinitely long piece of paper. It's worth looking into at some point. You can read through these notes on your leisure in this recording, but that's not really, but these are all different kind of insights about this. But let's talk about how we got there, okay? So the history of computer science basically starts with two very important things, one not listed here. The first is the abacus. It's not a computer. It's one of those, things with beads, still used throughout the world today. And it's just useful for doing data storage. Still need a human to operate each step, but it effectively turns a human into a computer. The other bit, which is not listed here, is the beginning of computer science, of one field of computer science was war, which we will talk about later. Specifically, encryption, making sure that your information was kept hidden from the enemy. We even named a famous cipher after Julius Caesar, the Caesar cipher, which we go over in week 7 or so. But really, computers started to become a thing in between the 1600s and 1800s, at least as a theoretical idea. Gear machines use the positions of gears to represent numbers. The idea here is you have a machine filled with gears. Again, I'm going over this very abstractly, very briefly, because the idea of what computer science is, what an algorithm is, those are important, right? A bunch of different people had this idea of just having a gear and how it was turned would kind of tell you where the number was. Babbage, Pascal, Leibniz all came up with this kind of independently or cribbed notes off of each other. But Babbage, she specifically wanted to create a gear-based machine that could print its output on paper. That brings us to our first programmer, Ada Lovelace, okay, which I have a picture of. That is specifically Ada Augusta King, the Countess of Lovelace. She is widely considered to be the first programmer. She has and her parentage is pretty much very interesting. Her father was, does anybody know this little bit of trivia? Lord Byron, which may or may not, people may not know. He was pretty much a rock star author back in the day. If you studied World Lit, you probably read some of his writings. He has an entire term named after him, the Byronic hero. But he was pretty much, he was a big name back then. Big enough that when he finally got divorced, people were still arguing about who was right in that side of the divorce years after both parties were long dead. So it was, it's amazing what people will argue about when they don't have YouTube, right? Anyway, but Ada Lovelace, she's often credited as the first programmer. She was raised because of her mother raised her with an emphasis on mathematics. And Babbage, he designed this analytical engine, as he called it, for this gear-based machine that prints stuff out on paper. The idea is it would take instructions from cards with holes punched in them and kind of turn the gears to kind of give that calculation. She took his notes, translated them, and added an appendix to them of her own, which had a program showing how it could be used to compute Bernoulli numbers, which are a specific type of number that are important to statistics, right? They're pretty cool, but not really cool enough to talk about to people who aren't interested in weird number stuff. But she took a paper, translated it, added her own notes to it, and then she talked about this, that she talked about how machines like this one could be used to work on things other than numbers. That was kind of her big insight. That was an idea about 100 years ahead of time. Unfortunately, she died at a very early age, in her 30s, to pancreatic cancer, I believe. And as she'd lived longer, we would probably seen a lot of interesting stuff. Computers really didn't take any kind of big accelerations until about World War II, which was the birth of modern cryptography. At that point, there were enough encryption the encryption algorithms had gotten advanced enough that you couldn't just hand a bunch of encoded notes to a mathematician and tell him to go and solve it, and then he would come back to you and answer in a few hours. Now it was basically you'd be waiting a couple years, if that. So it was the birth of modern cryptography, using machines to break the German cipher. There were two classifications of ciphers for the U.S. Army, ultra and magic, or rather intelligent. Ultra was the highest level intelligence in the German army, and military force. Magic was for the Japanese. If you had ultra magic classification, that would be make you pretty important. Anyway, that brings us to Alan Turing, who's often considered the father of computer science. He was a British man, and he worked on the German. He worked on breaking the German Enigma code, which was these very advanced machines that were able to encrypt notes and encrypt messages and make it so that, well, you're communicating with somebody and you don't know what they're saying, you don't know what the intelligence is. The reason this is important is because if you can decrypt things saying we are moving the troops over here, you can intercept them. If you're saying we are going to be patrolling in this area, or supply ships are coming this way, you can intercept that. You can seek those ships. Or we can move our own forces away. When you know what the enemy is doing, you can move around that and have a huge tactical advantage. It's massive. Eisenhower basically said that it was information from Ultra was decisive to an Allied victory. We're talking about 2 years being the estimate of amount of wartime that did not happen because of this intelligence information. Very interesting story. Unfortunately, again, Alan Turing was had his life cut short very early. Alan Turing was basically died for the crime of being a homosexual during a time where it was unacceptable to be gay. He was found out by his government. His government found out that he was gay, and basically he was given a choice: imprisonment or chemical castration. He chose the latter and later committed suicide. So there was, and the British government eventually formally apologized for their treatment of Alan Turing. But again, life cut short. In the meantime, he's known for not just the work that he did in World War II, but also for the idea of what a Turing machine is, basically a formal mathematical model for what a computer is. And more importantly these days, the Turing test. Can you tell whether something is an AI or not? Can you tell whether it's a computer or not? Our first computer, so moving on from that extremely depressing topic, what is the first computer? God if I know. I mean, like, the reason we go with Ada Lovelace as the first programmer is because we don't really have any better examples, any better argument to make for it. There's not really a clear first computer as we can say, this is a computer, this was the first one, and you can say, what this one? And like, this one's missing features in that one. A famous early computer is ENIAC, which is this thing over here, giant massive wall of computer right there, right? We're talking about so ENIAC stood for Electronic Numerical Integration and Integrator and Computer. We're talking artillery calculations here. Construction began in 1943, ended in 1946. Vacuum tubes, about 1,800 square feet, primarily used for artillery calculations. Since then, the name of the game has been miniaturization. Computers getting smaller and smaller and faster and faster. IBM introduced the first personal computer in 1981, basically bringing it to the masses. 90s saw adoption of the internet, which is a global system of network computers, which you use to this day. Computers, again, still get smaller and smaller and smaller, to the point that we carry around one in our pockets and don't even think about it. The biggest application that runs on the World Wide Web, on the internet is a program called the World Wide Web. That's basically when you go and look up a website, www. That program is so big that it requires search engines to go through it and find all the information in it. The big hot topic of today is AI, but more formally and more correctly defined as machine learning. We had a lot of it available when I was, a lot of ideas of AI when I was in grad school, but we called it machine learning at the time, because that really is what it is. There's a lot of great resources about how these actually work, but it involves basically finding the best algorithm that can complete tests and designing good tests for these things. The big AIs you use these days are what we call LLMs, or large language models. In other words, they are simply extremely large and extremely powerful versions of your autocomplete that's on your keyboard on a phone. That's a bit of a gross oversimplification, but it is effectively what they do. They don't reason. They just are really good at predicting what the next bit of information should be. But the big themes of computer science and programming have been miniaturization and scale. That is what has been going on for the past couple years. So with that, let me talk about what your first homework is in your lab. So there were a bunch of names in here in this. Part of your first assignment is to test that that Python works on your computer by creating a very tiny biography, printing out 3 sentences about a famous computer scientist who is not named Turing, Gates, or Jobs, right? Because if I didn't specify not to do that, that's all we get. My personal favorite is none other than this woman, Grace Hopper. Or more properly, Rear Admiral Grace Hopper. She was the highest ranked woman in the U.S. Navy. She was the pioneer of computer programming. She came up with a bunch of stuff. And part of her claim to fame is the first computer bug. I believe we have it here. Yes. The first computer bug. You may be wondering why when a computer breaks, why we call it, or a program breaks, we call it a bug. Well, because of the first one. Relay number 70 panel, moth in relay. First actual case of bug being found in the computer. It was literally a bug messing up the computer.
At least they kept it for the record.
They did. Now with that, I think I'll let you out a bit early because I've gotten through what I need to. I will be uploading this to YouTube later tonight and fixing that tomorrow. The rest of the lectures, I promise, are a hell of a lot more interesting and a lot more involved. Okay?